Hello, and welcome to a video that teaches you the science behind celestial objects. Stars are gigantic balls of hot plasma that reach to millions of degrees Celsius and have an enormous gravitational pull. These celestial objects are formed from molecular clouds in interstellar space, more commonly known as stellar nurseries or star-forming regions. When elements, mostly hydrogen and helium, make clouds in space, or nebulae, the group of particles are on their way to become a star. Of course, it takes many years to become one, as there needs to be enough gravity to make the nebula collapse on itself. Why, you may ask? Well, the reason why is a little something called a hydrostatic equilibrium. Nothing much. Nah, just kidding. A hydrostatic equilibrium is when a fluid has a constant flow velocity over time. To make things simpler, the reason why Earth's atmosphere hasn't collapsed into a thin, dense shell is because the pressure gradient force is acting upon it. Yet at the same time, the gravity that keeps the atmosphere in place keeps the pressure gradient force from diffusing the gases into space. So, when the gravity in a stellar nursery or nebula is greater than the pressure gradient force, is the time when the cloud collapses and turns into a protostar. The second stage of the birth of a star. Eventually, when a spinning protostar's temperature rises to millions of degrees Celsius, that's where nuclear fusion can start. On to nebulae. Nebulae form from the gravitational collapse of an interstellar medium, or dust if you will. Or to be more accurate, it's the matter between stars. Massive stars may form in the center and their radiation ionizes the surrounding gas, making the gas vibrate vigorously and produce a wavelength in the frequencies of the optical spectrum. That is exactly the reason for us being able to see what colors a nebula has. Different elements produce a different wavelength when ionized. Helium most commonly produces white to orange light. Neon is a red-orange. Argon is violet to pale lavender blue. Krypton is gray off-white to green. At high peak currents, bright blue-white. Xenon is gray or blue-gray. Nitrogen is similar to argon, but duller and more pink. Oxygen is violet to lavender, but dimmer than argon. And finally, carbon dioxide is blue-white to pink.